So now we're going to look at simultaneous equations, particularly solving simultaneous equations using the row reduction to echelon form. Now, before we go any further, I want to make sense of what we mean by row reduction to echelon form. And I'm going to give us this example. This is the number we are going to use to work out. But before us starting, I wanted to talk about some few important concepts, then we can actually start working out the number. So this is this. Now in row reduction to echelon form, we are going to arrange this in rows, but we're going to first say this is P, Q, and R. We pick out the unknowns. This is P, Q, and R, and we're going to arrange them in rows while just picking out the so this is row 1, row 2, and row 3, while picking out just the coefficients. So now I'm going to, what's the coefficient of the first equation? 1. Of P, the first coefficient of Q is 2. This is -1. This side equals is -1. Then 3, then -1, then 2, then 2, then 3, then 1. Now you should note that before you should always ensure that the coefficients are matching. This is P, 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 this is Q, 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 this is, and never forget to carry the negative sign. Another thing is you should always ensure that you rearrange in case maybe you rearrange so that it's easier for you to pick out. Okay, now in row reduction to echelon form, we are always aiming to have our final product. So for example, this is PQR. You have some things here, then this line, then this. The goal of whatever we are doing here is one to ensure that our final answer is, here we have 0, 0, 0, then everything else stays the same. So you can note that we're not going to make any changes on this first thing. Now, how do we get to this? We are doing it in two steps. We have the first step and then the second step. In the first step, we transform like we do it in steps. We don't change it at once to look like that. In the first step, as I said, this will stay the same, -1, -1. And now here we'll have to manipulate something here for this to become 0. So we'll also change this to also become 0. After that, we now pick this R1, R2, R3, pick this, then we have P, Q, R, 1, 2, -1, -1, 0, this. The dashes are representing the values. Then in this second step, we just transform now this last one to look like 1, 0. So we'll have now this. You see, so you realize that the first row doesn't actually change. Then now when we have this, maybe let's say we have maybe star, and here there is star, but this is P, Q, R. We can always pick out this, and let's say maybe if this is 5 and this is 5, shall say 5R is equals to 5. Then we can find the value of R as 1. But don't worry, we're going to see how we are going to do that in the example. But now another thing you should note, in the first step, we've said we want to transform R2 and R3 to look like this. But always remember, we are always going to have to compare them with R1. You're going to see what that means. You're going to compare R2 and R1. You're going to compare R3 and R1. It's the first step. I think it's easier to remember. First one. Now for the second step, we're only changing R3 to look like this. So we are going to compare R2 and R3. So I think this is the second step, R2. So now let's look at the example. Alright, so now we can look at the example. So this is what we have. So we said you have to pick out, these are the unknowns. We label this R1, we label this R2, this is R3. Then there's this separating with what is on the equal sign. So here it's -1, 16, 3. Then we start picking out. Here we have the first row. This is 1, 2, -1. Here we have 3, -1, 2. Here we have 2, 3, 1. So we want to receive the first step is we have to change this to, this is P, Q, R. Okay, the first, we're going to transform these two. The first one doesn't change, -1. So now I want to change these two. And we said in the first step, as we are now changing R2, we'll be comparing it with R1. As we're changing R3, we're going to be comparing it with R1. So okay, now let's start. So we're going to say what is R1. Here R1 is 1. What is R2? R2 is 3. Let me change the color. So you see I have this. Now on R2 I have 3, as 3 is here. On R1 I have 1, 1 is here, as you can see. Now what am I going to do? I'm going to interchange these coefficients and I subtract. So I'm going to say the coefficient, the R, okay, they're not even coefficients. R2 is 3, so I'm going to bring it this side. So I'll say 3 R1 minus R2. And we said our intention is for this to be, so I test this. I say, if I say 3 times R1, which is 1, minus R2, which is 3, I get 3 minus 3, which is 0. So meaning I've made this 0. Meaning I'm going to use this to transform everything here. So this is 3R1 minus R2. This is going to be used to transform this, this, and this. Okay. Now let's see. So I'm going to keep rubbing off the workings for each of these steps. So now I'm going to come here and say 3R1 minus R2. At this time I'm working at this point. So I'm going to say 3 times what is R1. R1 is 2 minus R2 is negative minus 3R1 minus R2. So 3 times 2 minus R2. R2 is negative 1, so I have this is 6 minus 1, which is 6 plus 1. This becomes 7, so this is 7. Then I go to the next column, 3R1 minus R2. So 3 times what is R1 here? This is negative 1 minus what is R2 here? This is 2. So this is negative 3 minus 2. This is equals to negative 5. So this is negative 5. Then we continue 3R1 minus R2. Then I come here and say 3 times what is R1? Negative 1 minus R2, which is 16. So I have negative 3 minus 16, which is equals to negative 19. So here I have negative 19. Now I'm going to go to this, but I'm going to first pause, then I clear this because we're going to be using the same space for each working. Okay, now this is what we ended with on the last part. So now we're going to go to R3. So for R3, I told you on the first step you're always comparing everything with R1. So we come and see what is R3. It's 2 here. Then R1 in the same column, like these are rows, these are columns in the same column. So then R1 is 1. So I told you interchange. So whichever way you do it, but me I'll choose to say 2R1 because I told you R3 is 2, but we bring it this side and this one, we bring it to minus R3. Then we test it with this very thing. 2 times R1, which is 1, minus R3, which is 2. So this is 2 minus 2, which is 0. So now we put here 0. Now we go ahead and go to this other column. Now we come here and say our formula now is 2R1 minus R3. So now we come and say 2R1 minus R3. And now we go here. 2 times R1, which is 2, minus R3, which is 3. So this is 4 minus 3. We have 1. 1 there. Now we continue 2R1 minus R3. So what are we going to have? 2 times R1 here is negative 1 minus R3, 1. This is negative 2 minus 1. This is equals to negative 3. Here you have negative 3. Then we come and say 2R1 minus R3, 2 times negative 1, this negative 1 minus, minus this 3. So this is negative 2 minus 3. Here I have negative 5. So we now see this is the second step. So now we are going to, after finishing here, now bring this down here, P, Q, R. We have 1, 0, 0, 2, 7, 1, negative 1, negative 5, negative 3. Here you have negative 1, negative 19, negative 5. This is R1, R2, R3. So finish the first step. And now on the second step, we're only going to be transforming R3. Okay, now this is where we were. So now I've just filled in these things. So I said in solving simultaneous equations using row reduction to echelon method, our final product we want is something like this: 0, this 0, 0. So what I was saying is, when you look at after the first step, we've already achieved everything on row 1, we've already achieved everything on row 2. There's a 0 here, but the only thing we've not achieved is on the third row, we still have a 1 here instead of a 0. So on the second step, I told you the first step we're always comparing with R1. That's why I see here for row 2, we compared row 2 with R1, then we generated this. Row 3, we compared everything with R1. Now for the second step, we're going to only be working with R3 because everything else is the way we want it to be. But we're going to be working with R3 while comparing with R2. And I said that easy way to remember it is, since this is the second step, comparing with R2. So now let's come and do the same thing. We say R1, and we say, we say R2 since and R3. What's the coefficient of R2 here? It is 7. What's the coefficient of R3 here? It is 1. So I told you we always interchange. So we're going to say 7 R3 minus R1. Then we try it 7 times. What is R3? 1 minus, this is R2 minus R2. So this is 7 minus 7. This is 0. So this is already 0. And this is 0. So now let's keep going. So now here we have the expression is 7R3 minus R2. So 7R3 minus R2. So we also do here 7 times what is R3, negative 3, minus R2, that will be minus 5. So this is negative 21 plus 5. So negative 21 plus 5, this is negative 16. So I put here negative 16. Then I continue 7R3 minus R2. 7 times what is R3? Negative 5 minus R2, negative 19. So this is negative 35 plus 19. So I have negative 35 plus 19. What do we get? We get negative 16. So now we can put here, this is negative 16. So now we've reduced, we've used row reduction to echelon, but now we have to find the answer to solve this equation. We've reached this point. So now when we do this, we're going to use the coefficients. We're going to say using R3, this R3, we're going to say negative 16R. As you see, it's negative 16 on R is equals to negative 16 divided through by negative 16 divided through by negative 16. R is 1. And now we can say using R2, this we're going to say 7Q minus 5R is equals to negative 19. So if you say 7Q minus 5 into 1 is equals to negative 19, you're going to get Q as negative 2. Remember, we've seen that the first row is unaltered, so we can just pick it as P plus 2Q minus R is equals to negative 1. So we substitute, this is P plus 2 into negative 2 minus 1 is equals to negative 1. We get our value of P as 4. So to solve this equation, you can compare in the video solving using substitution, we got the same answer.